So I'm going to go through today about 40% of the test. Later on, I'm going to film a very quick portion that counts for about 20 more percent. And then the remaining 40% will be, I'm going to do tutoring tomorrow. Tomorrow will be all word problems, which for some people is the most difficult part. If you were in a period today, period 1 or period 4, you would solve problems that are going to be similar to those on the review and on the test. Let's get started. The first goal is you can convert from decimal notation into standard notation and vice versa. So I want to convert this into hours, minutes, and seconds. So notice that we have the exact same units. So I'm going to take the whole number 6, and it accounts for 6 total hours. Then I'm going to take the decimal portion and ask myself, how many minutes are in an hour? There are 60. I keep the whole number 17. And then we take what is the remainder, 0.7, and ask ourselves how many seconds are in a minute. So 0.7, there are 60 seconds in a minute, times 60, 42. The second part, we're going to do vice versa. Oops, sorry about that. And so now we're going to go back into decimal notation. So I have, if somebody can please go ahead and allow the person to come into tutoring by admitting them, please. We have 3 miles, 4,820 feet, and 4 inches. So 3 full miles. And now this portion is going to be a portion of a mile. So I want to first write this all as feet. 4,820 feet, and then we have a remainder of 4 inches. So how many inches are in a foot? There are 12. I'm going to write that on my calculator. This is all in terms of feet now, but I want to write it in terms of only miles, and then I'll round to the nearest thousandths. So this is in terms of feet. I ask myself, how many feet are in 1 mile? There is 5,280. And so I'm going to write this down. Now, how far do I go? I want to go to the thousandths. That's 3 places after the decimal. So 912, so 0.91. And whether I decide to keep it a 2 or round up is based on the number behind the third digit when you're rounding to the nearest thousandths. The 9 says bump up. Okay, moving on now. We're going to go to number 3 and 4. The remainder of the problems we do today has a learning goal of utilizing a graphing calculator to adjust the window and identify key features of a function. So here's my function. I can always tell you, let's reset the second plus 712. Go ahead, please, and make sure that you have your microphone on mute. I'm going to plug in x squared plus 5x minus 3. What the directions say? We're going to come back over here and just mute whoever needs it. 1 second. Got it muted now. Okay, now here's the part that I saw a lot of students who started on the review make a mistake on. This specifically says you need to adjust the window. So I go to window and I go to the x's. Minimum is the smaller of the 2 numbers. So -8 to 4. And then the y's, the minimum for the y is please shut the door. I'm tutoring. Thank you for listening. He's in a meeting. That didn't take very long before we had one that interrupted. Okay, let me lock the door, guys. 1 second. You go play or do something, but please do not interrupt me. Sorry, guys. Okay, so I've adjusted the windows to exactly what it says. Now I go ahead and graph, and then I draw a picture that looks like this. Okay, so it comes in this way, comes down, and comes back up. And the question is, what is the y-intercept? When you press trace 1 time, this will be the y-intercept. Oops, I don't know what I hit there. Well, I will tell you this. Whenever you find the y-intercept, I must have hit something else. Whenever you find the y-intercept, x will always be 0. So I can go second trace the value, typing in 0. And we have a y-intercept of 0, -3. Going on to number 4. Thank you for admitting people that are trying to get in. I'm going to reset again, second plus 712. Typing in here, so I have x to the 3rd. A common mistake I saw students make is that they didn't then use the arrow on the calculator to adjust this. So they would keep typing in here. We want to go back there and delete all of those. And after we type in the exponent at 3, I'm going to use the arrow to bring it back down. Plus 3x squared minus 4x plus 2. So I'm going to graph this. This does not tell me a window to use, okay? So we have our basic window. And then I want to fill in what is going to be the points that correspond to these specific X values. So what is the output? Notice that these values are above 15. When I go to windows, the X's are above 15. Here, my X max only go to 10. So I need to go to something past 15.6. Let's go to 16. Now, how do I come up with these values? We're going to go second, trace, value, and typing in 15.3. And it says here to round to the nearest tenth. So my answer would be, if I move this here off to the side, would be 4,224.6. 0.6 here if I move this in. And just for the point of time, not to waste for you, as I do these, I may not write these down, but you get the idea of what we're doing here. So if I zoom in here, if you happen to be looking at your phone, and we round this now to the nearest tenth, be 4,304.1. Again, we have two more to do. Second, trace, value. I'm not going to do the last one. You guys get the idea of this. And we have 4,384.6. How will you know what to round to? I will make sure that that is given to us. Okay, last problem on this page. Now, this was a problem that a lot of students just didn't know technically how do we write this symbol, this absolute value symbol. So to do that, there's going to be 3 keystrokes. You're going to find the button that says math. You're going to scroll across the top to where it says NUM for number, and then you're going to select ABS for absolute value. So I'm going to start by resetting everything, going to Y equals, and now I want to start with the absolute value. So again, I go to math. I'm going to put this up so everybody can see. Here's math. I want to go to NUM for number, and then I select ABS. Now inside is going to be X subtract 2, and then I have to use the cursors to going back and subtract 2. I'm going to graph it, and then let's see what it says. It says, using the graphing calculator, sketch a graph in the standard window. Standard window just means we're not adjusting the window. So I'm going to sketch a graph that looks like this. Okay, coming down through the origin, looks good. Coming down through the origin, going back. Right, we are going to go on right now to page number 2 and look at problem number 6. So problem number 6, again, we're going to reset the calculator after each problem. And I'm going to take the function that I provided, x to the third. As a reminder, we want to use the arrow key to bring it back down, plus 2x squared, subtract 4x plus 2. Let's read this question. The question says, find the relative maxes and the relative minimums. Okay, I just want to come off to the side here and draw a little picture just to give us an idea of here what things look like. Okay, so if I draw this picture for you, this arrow insinuates as we go to the right, it's going to continue to go up. So this is going up at a slight diagonal, and it will continue to go up. This arrow means it never stops going up as you move to the right. And this arrow means the same thing. As we move to the left, this function will continue to go up as we move to the left. So what does that mean? In order for there to be an absolute maximum, that means there's one and only one point that stands out as the absolute highest. Another word for absolute maximum would be global maximum. I'll use the term absolute. So I'm looking for an absolute. There's not just one point that stands out at the highest. There's high points here, but they're not the highest. Why? Why can I not identify one and only one point that's the highest? Because it never stops going up. And since it never stops going up, I can't just identify one point as being the highest. That's why an absolute maximum does not occur. For this graph, there is an absolute minimum. Again, that means one and only one point that stands out as absolutely the lowest. This is the absolute minimum. Now, what are relative maxes and minimums? They still mean a high point or a low point. It's just not the highest or the lowest. So when I tell students to look at this, let me actually go back over this graph here so it stands out. I'm using this just as an example before we actually use this function. So if I were going to identify the relative maxes and minimums, we know this is absolute. So I'm just going to abbreviate absolute minimum. Okay, so this is a high point. It's just not the highest point because we don't have the high point on this graph. These arrows, again, keep going up. So we would call this a relative maximum because it's a high point, just not the highest point. Just like this is a low point, just not the lowest. So it's a relative minimum. This is a relative maximum. This is a relative minimum, just to give you an idea. Okay, let's go back here. So I've plugged this in. Thank you for allowing students into tutoring. This is what it looks like. And now we want to identify what is the relative max and the relative minimum. Okay, so what we're going to do is we want to know this point and this point. Okay, I can see this. If I want to change a window to make it a little bit larger on top for Y's, I can, but I don't think I need to. So second trace, and I'm going to go to maximum. This is a relative. Now, if I draw this picture, just so you guys can get a glance of this, this is what it kind of looks like. It comes up, goes down, and comes back up. So this is what we call a relative max. This is what we call a relative minimum. Now, does this particular problem have an absolute max and an absolute minimum? It doesn't. Why does it not have an absolute maximum? Because we have an arrow that goes up. So as it moves to the right, it keeps going up and it never stops. We can't pinpoint one and only one point that's the largest. And we can't pinpoint one and only one point that is the lowest. That's why an absolute maximum minimum do not occur in this particular graph. Okay, how do we identify the absolute maximum? I first am going to go all the way up to the top, the very highest point, and then I'm going to follow the directions, go to the left. So I just use the arrow and go slightly to the left and press enter. Go to the right, I go slightly to the right and I press enter. Then I go up to the very highest point and it says guess. That means I press enter and this is the maximum. So it says to round this to the nearest tenth. So to the 10th would be, negative 2.0 and 10. This is going to be the relative maximum. Again, this is our relative minimum. So second trace minimum, I'm going to tell you to use this little cursor and go all the way down to the lowest and then follow the directions. Somewhere to the left, enter. Somewhere to the right, enter. And now guess on the lowest point. Okay, we're going to round to the nearest tenth. So this is going to be 0.7. And this is going to be 0.5. Okay, this is my relative minimum. So relative maximum and relative minimum. All right, let's look at the next one. Use the graphing calculator to sketch this, and then we're going to use the calculate button in order to achieve an answer. So remember, all of chapter 1 is saying, hey, what should you have learned in Algebra 1, 2? And now you should have learned the algebraic part of it. Now, how can we use the calculator in order to be able to literally analyze things further, especially when it comes to word problems? Second plus 7, 1, 2. All right, plugging this in. So chapter or unit 2 will be a lot more algebra based. We're just introducing the calculator and learning the different key features of the calculator. So I'm plugging it in. The big key here is that when you do the numerator and the denominator, you make sure it's in parentheses. And now I'm going to graph it. Making sure I have 2x minus 1, perfect, and x plus 3, perfect. Okay, graph. Now notice, remember, we can never have 0 on the bottom. So what would you substitute in for x that would cause the bottom then to be 0? And if you're not great with that, just take the bottom, set it equal to 0, and isolate the x. In this case, we'd subtract 3, and 0 subtract 3 is negative 3. We do not want x to be negative 3. And if you come over here and notice, x equals negative 3. If I put that in, well, we can't put that in here actually, but if I drew a line here at x equals negative 3, we would never see a point. And the reason why is because x can never equal negative 3. It'd be undefined. We'd be breaking a math rule here by having 0 in the denominator. So I know for this problem, x can never equal negative 3. So I'm going to draw a little dotted line here and just copy here what we have. We have part of the function going this way and part of the function going this way. I'm so sorry. I have a bratty little 7-year-old right now who wants to be fed. He is hungry and he's used to eat supper at 4:30. My fault. Benjamin, you're not being patient and I'm disappointed. I am disappointed. Please be patient. Okay, so this is what we have right now. And now how do we calculate these points? We're going to go second trace value. I'm typing in -1 and writing down what we have, -1.5. Okay, type it in -2. Second trace value, type it in -2. We have -5. Remember I said we can't have a -3. So what happens if we plug it in? If we plug in -3, we're going to see no answer. It's just blank. So what do we do here? We call this undefined. Okay, undefined. Now, would I accept if you put no answer? You could write no answer, but really undefined is the math term. We can't define an output when the input is -3. Moving on right now, it's number 8. Number 8. We're going to identify the zeros. Remember, another word for zeros is x-intercepts. Excuse me, x-intercepts or roots. So I'm going to clear the second plus 712. I'm going to go up to y equals x to the third plus 3x squared, subtract 6x, subtract 7. Okay, looks good. Let's graph it. This is going to give us a helpful hint. We can have up to 3 x-intercepts that are possible. So the largest exponent on a variable will tell you the maximum number of x-intercepts, and we can see 3. Now, a lot of students in the past have made the mistake when we're trying to find precise x-intercepts by hitting trace and then just going like this and going, the answer is, let's see, about -0.9. We need to be precise with this. So second trace, let's try the second trace 0. And remember, I'm going to chart here. I choose any number to the left. So 1, 2, 3, 4. Any number to the left of -4. Let's go -6. Now, any number to the right, but it has to occur before the 0. So 1, 2, 3, -3. Now, my x-intercept is in between these temporary vertical lines. I press enter, and this is the exact answer. Here it says to round to the nearest hundredth. So one answer is -4. I'll zoom in here. If you were going to round to the nearest hundredth, it'd be -4.05. -4.05. This is the same as 0. This is virtually equivalent to 0 in scientific notation. Let's do the next one. Again, it looks really close to -1, but we need to be precise. So I'm gonna go to the left. So I'm gonna go to -2. I'm going to go to the right, any place to the right. I just can't go all the way over here. So let's do 1 so everybody can see it. It's in between there. I press enter. And another one is -0. Remember, we're going to round to the nearest hundredth. So 888 would round to -0.89 and 0. For all zeros, which are x-intercepts or roots, we always have a y value of 0. And lastly, second trace 0. 1 and 3, it's in between, and we have 1.94. We are almost done. Stay with me. Hopefully you have more patience than my son. Okay, since I know a lot of people struggled with number 7 in the past, we're going to do another problem like it. So this is number 9. I'm plugging in this rational equation. Make sure you always put parentheses on the numerator and on the denominator. And the first thing I ask myself is, what would cause the denominator to equal 0? And if you're not great with mental math, set this expression in the denominator equal to 0. I'll have to move 1 to the opposite side and with -1. We can see there is no output when x is -1. Okay, when x is -1, there is no output. I draw a rough graph of what this looks like. And now, how do I go ahead and find these exact output values? Second trace, my value at 1 is 0. Second trace, my output at 2 is 1. Second trace, my output at 3 is 1.5. Okay, let's go on to our very last page. So we've done 9 problems. If you're joining me late, thank you for coming, and I will take this recording and post it for anybody who can't be here live. Okay, the next thing, we're going to find the exact zeros, but instead of having something to the third, we have something to the second. So as a reminder from freshman year, that means at most I will have 2 x-intercepts. So I'm going to do second plus 712. Coming back up here, we should be done. If you're still with me, we should be done in the next 5 minutes. We have x squared, subtract 5x, subtract 3, and I graph it. Okay, I want to identify the exact x-intercepts here. Second, trace, and another word for x-intercept is 0. So I just go somewhere to the left, n to the right, and now it's in between, pressing enter. Negative 0.5, it says to round to the nearest tenth, negative 0.5, and then 0. Now let's do this one. Second trace, 0. Somewhere to the left, somewhere to the right. 3, 8, guess. So I have 5.54. 5.54, but we're only rounding to the nearest tenth. And remember, this is the same. Really, it's equivalent to 0. Scientific notation there. Let's go on to the last two. And the last two, you will be expected to use algebra to write an equation that goes through these exact 2 points. So my equation will be a linear equation. And I'm going to start by identifying what is the m. The m will be the slope. And so I'm going to come up here and say this is the first point, x1, y1, and the second point, x2, y2. All right, here we go. So when we do this, it's always y's on top and then x's. So y2 minus y1, x2 minus x1 in that order. The y2 value is negative 1. The y1 value is negative 4. The x2 value is 0, and the x1 value is negative 10. Off to the side, I'm going to write this. Negative 1 subtract to negative 4, and 0 subtract to negative 10. Remember, you can plug this into your graphing calculator, but remember, 2 negatives make a positive. Negative 1 and 4 would be 3. 0 plus 10 is 10. If you have younger siblings, you can understand how annoying this is right now to have my son in the background knocking on the door asking for food. I'm so sorry. So this is the slope. M equals 3 over 10. What do I do now? I saw some people today that were having the review that stopped at this point. Now you go back and you choose whatever order pair makes more sense to you. To me, I'm like, ooh, these are small numbers and it has a 0. 0 is going to replace the x, and negative 1 is going to replace the y. So negative 1 equals, and if you see me make a mistake, just let me know. 0 times anything is 0. So my b is negative 1. Here's my m, here's my b, and now I can write the final equation. 3/10 x minus 1. Very last problem. Again, x1, y1, x2, y2. Always remember your y's go on first. So y2 minus y1, x2 minus x1. So 15 subtract a negative 3. 15 subtract negative 3 over 1 subtract negative 5. Double negatives make a positive, and 15 plus 3 is 18. 1 plus 5 is 6. And now what happens if you don't reduce this? You'll still get the right answer. I wouldn't take anything off, but it does reduce down to 3. Y equals 3x plus b. So I've taken this general equation, y equals mx plus b. I've now solved for the m, and now I need to figure out what is the y-intercept, the b. So come up here and choose either of these. I'm going to choose 115 because it doesn't have negatives. 15 is the y, and 1 is the x. 1 times 3 is 3. To isolate the b, I subtract 3 to the opposite side. And now this is my b, 12. I have my b, I have my m, and here is my final. Here is my final. So the next study session I hold will be tomorrow. Tomorrow's when we're going to go over word problems. Let me come up here, come back here, give me 1 second. Tomorrow will be word problems.